All right, guys, lesson number 12 is unit conversion. So this might look familiar to you depending on what kind of science class you are in or have taken. I think they do a lot of unit conversions in chemistry. I could be wrong. Maybe it's physics. I don't exactly remember, but some of this might look familiar to you or it might look brand new. So give me a chance to teach you how to do some unit conversions because it can be kind of confusing, especially if you know someone who's really good at unit conversions. You're like, how do you do that? But I'm going to give you a pro tip to try and help simplify and help you decide whether you should multiply or divide. For all the unit conversions, make sure you're labeling your units. Very rarely do I, like within my work, put labels on units, but for unit conversions, it is very helpful. So, number one, we have a printer producing posters at a rate of 42 posters per minute. For unit conversion questions, you will see like a number per something. And so look for that word per, and I am going to make a fraction out of that, and I'm going to label it, okay? 42 posters per means divided by. Minute means 1 minute, right? Okay, so I've written that. And now it's asking me to convert that to posters per hour. And in my head, even though I'm a math teacher, I can never remember, am I supposed to multiply or am I supposed to divide? I have to write it out. And what do I do with the 60? You know that there are 60 minutes in an hour, but here's the thing. We want minutes to cancel, and we want to be left over with hours. So that means that I know that there is 60 minutes in 1 hour, but where do I put the 60? Do I put it on the top or the bottom? The reason why it goes on the top is because minutes right now is on the bottom of this fraction, and when I multiply, I want the minutes to go away. So that's why I'm labeling 60 minutes over 1 hour. Now the minutes are gone, and I'm left over with posters per hour. So like the words here and these are really important. And I'm just in my calculator taking 42 times 60. Divided by 1 doesn't do anything, so you can ignore that. But that's how I get 2520. And the label is posters in the top, hours in the bottom. That means posters per hour. So in the box, I am just typing 2520. Okay, number 2. We have an International Space Station orbiting Earth, and it goes at a certain speed in miles per second, and we need to convert it to miles per hour. What do I do with the 60? Great question. I am finding the first per thing that they gave me, and I'm writing it as a fraction, and I'm labeling it appropriately. So 4.76 miles per 1 second goes in the bottom. What is the space station's average miles per hour? And again, you know that there are 60 seconds in 1 minute and there are 60 minutes in an hour. So let's first convert seconds to minutes. And I'm putting the 60 seconds on top and the 1 minute on the bottom. There are 60 seconds in 1 minute, but the question is, do you put it in the top or the bottom? You want the seconds to cancel, which is why I'm putting 60 seconds in the top and 1 minute on the bottom. So after you do this, seconds are gone and I'm left with miles per minute, but I'm asked for miles per hour, so I need to convert again. How do I do the minutes part? Well, there are 60 minutes in an hour, so do you multiply or divide by 60? So the minutes right now is in the bottom and you want it to cancel, so you got to put it in the top. So I'm putting 60 minutes in the top divided by 1 hour. Minutes now cancel, and you can see that I have circled the units that I have left. I have miles in the top and I have hours in the bottom. It's really similar to in Algebra 2 when you were factoring a bunch of stuff and canceling a bunch of stuff when you were multiplying and dividing rational expressions. It's kind of the same thing. We're canceling words here. Seconds in the bottom, seconds in the top. Those are gone. Minutes in the bottom, minutes in the top. Those are gone. What am I left with? Miles in the top and hours in the bottom. You can see I wrote like a division sign, divided by or per. And then how do I get the actual number answer? Well, you just take 4.76 times 60 times 60. And all the ones in the denominator don't make a difference, right? So that's how I get 17136. And the label is miles per hour. Number 3. Sometimes for these you can set up a proportion if that seems easier to you or if that seems something that comes a little bit, fresher in your head. We have a person M miles from a flash of lightning, and the length of time it takes a person to see the lightning to the moment the person hears the thunder. I love thunderstorms. This problem makes me excited. The ratio of M to K can be estimated as 1 to 5. There's my ratio. 1 to 5 or 1 per 5, and I'm writing it here. And the 1 is the M to K. They're telling me that the M is miles, so that's why I labeled M for miles. And that the K is in seconds, so that's why I labeled seconds. So it's kind of weird the way you have to like kind of hunt through the words of this question, but whatever. That's why I have my miles on top and seconds on the bottom. And it's asking me how many miles. So I'm putting an X. Does it go on the top or the bottom? Well, since this is an equal sign right here, you want to keep miles in the same spot because we're doing a proportion here. So we're not multiplying to cancel. We actually have an equal sign here. I'm just setting up a proportion. This is another way to do these problems. And let's see, the time interval is 25 seconds. I put seconds in the bottom, so that's why I'm putting 25 seconds here. So now we can just cross multiply. You can go 5x equals 25, or you can notice that you take the 5 and multiply by 5 to get 25, which means 1 times 5 gives you 5. Either way, you do that problem, you end up with 5. So a proportion can also be helpful for problems like this. Now getting a little bit more difficult, population density, the number of people that live in like a square mile, or in this case, square kilometer. You can imagine that the population density in the city of Chicago, with all the like high-rise buildings and a ton of people living in a small area, versus the population density in Palatine, where houses are a little bit more spread out, is different. And we don't have as many people living on a certain like stamp or footprint of the earth that we do in the city of Chicago. But anyways, we've got people per square kilometer, and it increased from 2.5 to 3.3. Again, it's people per square kilometer. And in this time period, we have the land area of Iceland, which is that number. Okay, this is already getting a little bit confusing, so let me start writing some stuff out. What does the 2.5 mean? In 1990, there were 2.5 people per square kilometer. So remember when you see your first like per, write a fraction out of it, and I'm using the 2.5. I'm going to do another one with the 3.3, as you can see right here. And I'm going to have to convert both of these. So it's like two numbers in one question, basically. And the land area was 100,250 square kilometers. So I already labeled the 2.5 people per square kilometer, and I'm going to multiply by the number of square kilometers that we are given in the question. And look, that's going to cancel my square kilometers. And I did the same exact thing down here with the 3.3 people. I put the kilometers squared here in the bottom, and that is the kilometers squared here will cancel. So in my calculator, I'm just taking 2.5 times 100,250, and you get this many people in 1990. You'll notice my work is very organized, and I'm labeling everything so that I can keep it straight. But I'm doing the same calculation down here, 3.3 times 100,250. It's that many people in 2014. And it asked me, what's the difference? How much did it increase? How many people? So what is the difference between these two numbers? You can see I just subtracted, and that is how I got my difference. Number 5, pure beeswax has a density of 0.555 ounce per cubic inch. I know where we're going with this. I'm making a fraction out of that right away. And I labeled ounces over cubic inches, which means inches to the third. An online company sells the beeswax $8 per ounce. So do I multiply or do I divide by $8? It get kind of confusing. I want the ounces to cancel, and it tells me that it's $8 per ounce. So that's why I'm putting the 1 ounce in the denominator and the $8 on top. Okay, so that's going to cancel my ounces here. And in my calculator, I just have to take 0.555 times $8, and it gives you $4.44. And the label on the $8 is just the dollar sign. And the only thing I have left in terms of labels down here is inches to the third. And it asked me for what is the price in dollars per cubic inch. That's exactly what I have, dollars per cubic inch. So the answer that I'm going to type in is 4.44. Number 6, we have a population density again, 290 people per square mile. There is my fraction. And in this case, I can set up another proportion. This is just another way to do this question. The people in Worthington, there's a population of 92,800. So since it's an equation and I'm cross multiplying, people go on top and square miles go on the bottom. And so I'm putting the 92,800 in the top, and I'm just going to cross multiply. So when you cross this way, you get 290x. And when you cross this way, you get 92800. Divide and you get 320. There's a cross multiplication proportion question. We've got a camera, and it has a depth of 58 fathoms. What's the depth in feet? And I have a proportion or a scale that I'm given. I don't know what a fathom is, but allegedly it is 6 feet. Okay, cool. So I'm putting 1 fathom over 6 feet. And in this case, I've got 58 on this side. Where does that go? Well, luckily I put fathoms in top. And again, it's a proportion. So I'm keeping fathoms here, which is why I put 58. And it asks for what is the depth. The depth in feet is the x in the denominator. So cross this way and you get 348. Cross this way and you just get x. Okay, number 8. I've got this person going for a midnight ride. Doesn't that sound fun? He would have traveled 11 miles in 26 minutes. Another way of saying that is 11 miles per 26 minutes. And so that's how I'm starting. And you notice that I'm labeling miles and minutes. What's the average speed to the nearest tenth? So we're going to round this answer in miles per hour. Okay, so I know there's 60 minutes in an hour, but where do I put the 60? Do I multiply or do I divide? Well, minutes is in the bottom, so minutes has to go in the top here so that I can cancel them when I multiply. And I've got, in my calculator, I've got 11 times 60 divided by 26. Be careful about that. And that's how I get the 25.4 rounded to the nearest tenth. And what's the label? I still have miles left, that goes on top, and I still have hours in the bottom. So miles per hour. Oh, cool. That's what they asked me for, miles per hour. Let's see, number 9. Which of the following is equivalent to 90 kilometers per hour? And we're given a conversion factor. So the first per thing gets written as a fraction. 90 kilometers per 1 hour. And I know that I can convert it into meters. Okay, cool. So I'm given this conversion factor. Do I put 1 over 1,000 or do I put 1,000 over 1? Because I want the kilometers to cancel, I'm putting 1,000 over 1. The 1,000 meters goes on top, the 1 kilometer goes on the bottom. And I'm left over with 90,000 because I take this number times this number. And the label is meters per hour. Meters per hour. That's not what they asked me for. They want kilometers per hour. Okay, cool. Oh, which of the following is equivalent? Look at all the answer choices. They need to convert this to seconds. My bad. I'm currently in hours. I need to convert to seconds. So how do we do that? I have 90,000 meters per hour. What do I do with the 60? Well, can you figure out hours needs to be canceled? So I need to put hours on the top, and I need seconds to be left over. How many seconds are there in an hour? Well, there's 60 seconds per minute and 60 minutes in an hour, so 60 times 60 is 3,600. Hours cancel, and I'm left over with 900,000 divided by 3,600, which gives you 25. And the label on this is meters per second because hours cancel. So that's how I got the 25. So I had to do several conversions in that one. We're getting harder and harder. Okay, last one, number 10. A distance of 61 furlongs. What the heck is a furlong? We got some conversions here. Okay, cool. But I have to take the 61 furlongs, which is what I started writing it with, and you'll notice that I'm labeling. And I'm going to first use this first conversion factor, 1 furlong per 220 yards. And I want furlongs to cancel. So you'll notice I put the 1 furlong in the denominator and the 220 yards in the numerator. And so I take 61 times 220 and I get this number, and the label is yards. Okay, great. But I need to be not in yards, I need to be in feet. So now I'm going to use this conversion factor. And where do I put the 1 yard? Well, since yards is currently here, I need it in the denominator to cancel, which means the 3 feet goes in the top. And so again, yards are gone now, and I'm taking the 13,420 times 3, and I get 40260. And what is the label? Yards are canceled, and I'm left over with feet, which is exactly what I wanted. So in the box, I'm typing 40260. Hey, if I went too fast on this, come see us on an optional Friday. Thanks for watching, and that is your crash course on unit conversions.